Welcome, Lin Sun. I'm so excited to interview you today for the podcast. And I'm sure everybody's going to gain a lot of great information about service mesh and related topics. So, welcome to the podcast.
Thank you so much for having me, Ben. I'm excited to be here.
Could you tell us something about your background? And you currently work for Solo Systems, but what have you been doing over the past, years that you've been in the industry?
Yeah, so I actually joined IBM almost 20 years ago, and I was graduating out of college and just landed a job there. And I never thought of, moving out of IBM. I thought I would actually just retire, at IBM. But because of the pandemic, so I've been, sorry, I forgot to mention what I was doing at IBM. So I've been a software engineer, started in testing, and then moved to development, and then moved to team lead and software architect at IBM. So my last job at IBM, I was leading a team of developers at IBM, contributing to the Istio open source project. So as you know, IBM was a founding member of the Istio project. So it's a really good job. I love it. I never, thought about moving out of IBM. But because of the pandemic, sometimes you have a lot more free time and you start to think through what if a different job, right? It all happens at an interesting timing that service mesh is really, faster growing. And, I had Edith Levine, the founder of Solo, reach out to me and it just resonated with me.
Very cool. Now, I have to say, well, the topic of patents in technology, software, and so forth is not always a popular topic because sometimes there are these, um, you know, companies, people, whatever, that are kind of called patent trolls who create patents around things that actually may already exist, but they want to capture that technology and profit from it. But let's just uh, state for the record that you are not a patent troll, but you have how many patents to your name?
I'm definitely not a patent troll. And before I leave IBM, I think I have 207 issued. There's probably more now. But yeah, it's been an amazing journey at IBM doing patents. It's like my side hustle, right? What I do outside of work at IBM. And our company was very supportive of that effort. Let me tell you, most of my patents are nothing related to my job. It's actually a lot of time I was using social media, I was using my mobile phone. I thought of what if this, what if that? And then we brainstorming in a patent group. And then we were like, wow, this is really interesting. We haven't seen anybody implement this. Why don't we, go through the patent process and, see if it's a valid patent. And it's just been fascinating to see your idea, people like your idea and people willing to write out a patent application for your idea.
Yeah, it's interesting. So about 207 patents, and coming from someone who has, or hearing this, and I'm a person who has zero patents and never even attempted one, it's pretty amazing. And so instead of maybe a patent troll, maybe you're more like a patent hobbyist or something like that. So
Yeah, it's
that's a
kind of
good.
like a hobbyist. Yeah, I mean, our company kind of reward us really well too. Like we got a lot of money out of patents. The whole IBM system was also building your career, technical career on patents too. Like my role at IBM, I was a senior technical staff member. And in order for you as an engineer to promote to that level, you have to have at least, I think, one or two patents issued. So it's an interesting dynamics at IBM.
So they certainly couldn't ignore you. That's great. Now you leave IBM, you go to this startup, which, as I understand it, has actually become very, very successful. And I think you landed a very recently landed a very large, what is it, round B or something like that of funding.
Yeah, we just had a round C.
Awesome.
It's 1 billion valuation. Yeah, it's 100 plus million as for our round C that we got the money from venture capitals. It's amazing. Yeah, it was a very, I would say it's a pretty risky decision, right? When I joined Solo was February this year, the company just went through round B, I believe, towards the end of last year. So it was a pretty risky situation for me to join. It's like a startup, you don't have a lot of money. There's a lot of talents in this company, right? How am I going to survive, right? And plus, I have family I need to take care of. Kids were working from home early this year. Finally, they're back to school. Just a lot of things to think through. But on the other hand, I thought of, what if I don't take this role? I think I'm going to regret, in a few years. So that's what triggers me to move.
Yeah, that's really a nice story actually, and I think the grassroots kind of concept of wow, this looks so um, interesting to me, so compelling that I have to leave this kind of secure, place where I can actually thrive. It's not just secure, but I'm having a good time at IBM and I'm thriving and so forth. And yeah, but I want to take some risk here because I believe in this. So that's a really great story. Now, I think probably like me, a lot of people know something about service mesh, but maybe we're not, experts in it. So, coming from an expert in service mesh, what would you say? How do you explain service mesh, and how does Istio, the product, play into that?
Yeah, so I think service mesh is a really interesting space, especially with developers are looking into moving their monolithic to microservices. I think COVID really helps our users adopting microservices and distributed cloud, right? So service mesh plays a critical role in that space by instead of each developer in their services to solve the problem of network are not always reliable. You can't really trust anybody. You have to secure your connections. You have to check the identity before you allow the connection. You have to figure out how do you observe what's going on within your microservices. So instead of relying on each developer to solve these challenges in their microservices, Service Mesh provide an interesting way to solve that at the framework level by injecting this Envoy sidecar proxy into each of your microservices and help you to solve that connect, secure, and observe problem, right? So when we talk about service mesh, there's typically the data plane, which has the Envoy sidecar, and also the control plane. So the control plane really is to help user to transform their intention of how they want to program the Envoy sidecar using a simplified language provided by the service mesh project, and then transform that into the complicated language that only your sidecar proxy can understand. In the case of Envoy proxy, which Envoy proxy configuration are not meant to be used by human, because the simple configuration could be like thousands of lines. It's very hard to understand. So that's the big value service mesh is trying to provide to our end user. First of all, to help them solve this connect, secure, observe problem. Second of all, to help them solve this problem in a simple way through control plane configuration, through unique API to allow user to configure the connect, secure, and observe configurations. Istio is the leading service mesh project out there. I would say Istio is definitely the most dominant service mesh in production today. Based on the survey, the most recent CNCF survey, we saw Istio is clearly leading in this space. I think the Istio adoption last time I saw was twice as much as Linkd and Console Connect, which are the second and third in terms of adoption.
Thanks. That's a really good explanation. Now, can you just tell us a little bit more about a sidecar? So, in terms of an application or microservice that's using Istio and Solo's distribution, what am I not only getting, but how does it actually work with my microservice?
Yeah, that's a great question. So the sidecar is a critical piece of your infrastructure. So this is something you want to choose very carefully, right? I mentioned Envoy sidecar. That's one implementation of the sidecar, which is the most common sidecar implementation used by many of our service mesh projects, from Istio to AWS App Connect to Open Service Mesh to Cons Kuma. We all landed on this sidecar proxy provided from Envoy. So that's one thing when you're trying to learn a little bit about sidecar proxy. Choose one that you can trust and battle test in production environment is important, which we know Envoy is very well tested in production environment, and it's a graduate CNCF project and all that. So that's number one. The number two is the sidecar proxy is going to capture all the incoming traffic and all the outgoing traffic for you by configuring the IP tables for the pod namespace. So the moment you have the sidecar injected to your microservice, it's kind of a changing your networking behavior by that capture of inbound and outbound traffic. So you have to make sure the service mesh you're picking, is capable to have flexibility to allow you to kind of control in the scenario that you may not want to start your application container until your sidecar proxy is ready, or you might want to have gracefully sequence shutdown between your application container and sidecar container, right? So those are the capabilities. It's also very important to watch out for when you select a service mesh. The third thing I think is also very interesting, that a lot of misconception about service mesh and performance. People are asking, how much is the sidecar is adding to the latency to my services, right? I think that's one angle to look at it. The other angle you really want to look at is what's the latency I'm also going to introduce if I'm actually doing the work the sidecar is doing, right? Because somebody has to do the work, whether you do the work in the sidecar proxy to solve that connect, secure, and observe problem with distributed cloud and distributed microservices. So if you solve that problem in your own application container, what are the latency you might be introducing, right? And also imagine solving that problem for different languages, because your application may have more than one language. So you have to kind of measure performance of all that, developing the language pack and all that. So those are the values and angles you want to take a look as you evaluate which sidecar solution is right for you and what's the value sidecar is adding to you.
Very well explained. Thank you. So a lot of people who listen to this podcast, frankly, are kind of like, domain-driven design interested individuals or practitioners. And so they might look at this conversation and say, yeah, but what does, Service Mesh, Istio, Envoy, any of these kind of components have anything to do with domain-driven design? Well, of course, much of the domain-driven design kind of, efforts reflect a microservices architecture because, when we want to separate bounded contexts one from the other and make that clean break, a lot of people decide to make that break very physical, right, using microservices. So do you think that is a a good reason for domain-driven design practitioners to consider Istio to help them? What do you think?
That's a really good question. So I think the first thing we want to look at is for folks using domain-driven design, is microservice part of their design, right? So if microservice is part of the design, it could be interesting to look at a service mesh project. The second thing I want them to think through is how many microservices do they have, right? What are the programming language of their microservices? The reason is if you just have one programming language, maybe the value of bringing service mesh is very minimum, because at the end of the day, you are comparing with, I need language pack for my language to do this connect, secure, and observe problem, was I'm actually need to learn this service mesh thing, and I need to learn how to operate the service mesh, right, and be able to upgrade and all that. So there's a learning curve you have to balance. If it's one language, you may find out it's not worth your time, especially if you already have that language pack doing your own thing. So that's the second thing I would encourage them to check. The third thing I would say is also check if your organization has some of the like GitOps pipeline, like the cloud native infrastructure, like observability system, Grafana, these Prometheus, these type of environment to help you observe what's going on within your microservices. Because if you don't have these environments, maybe the observed value from Istio is not going to be interesting for you because you're not ready yet, right, to be able to observe the activities among your microservices. So you want to look at your infrastructure, because we do recommend user to use GitOps pipeline to push through their Istio service mesh configuration so that they can propagate that to multiple cluster and roll back if needed. So it's important to have an automated process to support your service mesh adoption.
Yeah, and I can say that using GitHub as sort of like, let's push this to test or push this to production right now. I mean, that's a pretty amazing option that we have as a company and team, vLingo, have been using for some time now, and it's really amazing how productive that is. But as you say, I mean, this is a very forthright answer from you, saying it may not actually be something that you need. So you're not here just trying to sell licenses for solo, right? You're actually being pragmatic about this, and it's very good advice. So appreciate you doing that. Now, of course, there are many, let's say, obstacles or challenges to adoption overall. Did that sort of summarize all of the adoption concerns, or are there any others?
Yeah, definitely. So we talk about operation concerns, right? So first of all, learn a service mesh. So first of all, actually, before you learn a service mesh, you need to be able to select the right service mesh for you. So it actually typically means you need to learn multiple of them and select the right one for you. So once you landed on the right service mesh for you, then you have to focus on, what is the most important thing from service mesh that you want to focus on, adopt that one thing first and keep iterate on that, right? And then the next thing you're probably going to look at is, okay, there's a CVE out there, right? How am I going to upgrade my control plane? How am I going to upgrade my data plane? Wait, is there a downtime, right? Let's make sure we don't have a downtime. Let's make sure the data plane can stay up during the upgrade. So those are the things you have to look through. And then as you get comfortable with single cluster, the next thing you might need to look at is, how do I running my services across multiple cluster? Maybe, some of my services are running on-premise, some are in AWS cloud. How do I have priority-based failover, right? So I can send the traffic to my local cluster. If my local cluster, the service in my local cluster is not healthy, can I fall back to my service in a different cloud or a different Kubernetes cluster. So these are a little bit more complicated problem that you probably need to tackle when you need higher availability beyond a single cluster. So that's the other angle. The next angle you probably need to look at is if you need to build a little bit of customization, right? If you need to extend beyond what Istio provides. By either writing through Envoy filter or using WebAssembly. So these are the different options Istio provides. So there's actually a lot more just beyond the install and upgrade and pick a simple scenario to iterate. As you grow, there's extension aspect you have to focus. There's multi-cluster aspect you have to focus. A lot of question to be answered, I would say. Depends on, really your scenario and requirements.
Yeah. So yeah, a lot to think about. Would you say that there are some service meshes that are sort of simpler or easier to get into, and maybe just try out service mesh that doesn't take so much configuration and operational control that, so outside of Istio and Envoy, what might someone use just to try it out first?
That's a great question. Istio certainly was perceived as not very simple, right? Some of the user perceive Istio as not very simple, and I tend to agree with that. In the first 2 years on the project, this is like my 5th year on the project now. In the first 2 years, because of the bugs we have in the system, and also because of we were not as much focused on simplicity of our user. It's actually pretty hard to get Istio up running and get the sidecar injected, just get the basic behavior of service mesh. These days, I would say Istio is actually a lot more mature now. It's designed to handle simple scenarios as well. I would say most simple scenario is mutual TLS, right? I want to enable mutual TLS among 2 or 3 or 5 of my microservices. And Istio does that very well through one single resource. All you need to do is just apply that single resource on either globally or on a particular service or on a particular namespace, and then you're done. You enable the sidecar would automatically upgrade your connection from the source service to the target service with mutual TLS, and also automatically handle certificate rotation for you for your service. I think every 12 hours we do that. So that's a pretty simple scenario to do something with Istio. And in fact, a lot of users I work with, they always start with adopting Istio because their security team said, hey, you must have your connection secured. And, the easiest way to do that is using a service mesh like Istio. But some things with Istio are not so straightforward. Multi-cluster is definitely one of the example. It could be pretty hard to get it running and troubleshooting. Envoy filter, the extension I talk about could be complicated. So it really depends on what you are trying to achieve. Some of the simple scenario, are doable without any application code change. But some of the more complicated scenario does require like the propagate B3 headers. You have to make code changes to your application to make sure the headers are propagate. And that's a requirement across all the service meshes, not just Istio.
Thank you. So let's say that there are maybe many companies who are thinking ahead and saying, well, we're going to use this architecture, therefore we need a service mesh. But other companies, and maybe even more so, are reacting to situations that they've run into. And they're like, what are we going to do about these, downtimes? What are we going to do about controlling all the microservices and observability and things like that? Can Solo offer expertise around training and consulting in those areas, or are you purely a product company that doesn't want to be involved in that? How does someone adopt Istio, in a hurry?
That's a great question. To adopt Istio in a hurry, in your words, I think the right way is to find a partner, right? Find someone who can handhold you through the process so it's much less error prone. So you're absolutely right. Solo offers like glue mesh product, which help user to simplify their Istio adoption. We also offer Istio support, so you can use upstream Istio or OWA distro of Istio, which is based on upstream Istio, but we added like FIPS compliance support, and we added some type of different architecture support. But you get full support from us. We actually support more than N-1. We support N-4.
Excellent. Great to know. Yeah, so actually, Christian, you work with Christian Posta. He's the field CTO of Solo, and we've interacted on at least several occasions. He's the one who introduced us to the Glue API gateway, and which actually we support in our Vlingo Zoom platform. So you're saying then that anyone who uses the API gateway actually gets some mesh support in there?
Okay, that's a great question. So Solo has Glue Edge and Glue Mesh product, right? So anyone who has Glue Mesh Enterprise, we would offer them Istio support. So Glue Edge is separate, which is the API gateway product you are mentioning.
Okay, so just not to confuse anyone with that, and thank you for clarifying, because I thought, wow, look at that. We could say we support service mesh, but no, not quite. But that's fine. That's fine. Okay, so let's see here. Now, an interesting move that the Istio project took recently is that part of the Istio, I guess, package or platform, correct me if I'm using the incorrect terminology, but let's say the product was all microservices, and I think maybe there were 5 microservices in a certain area of the product, and the team decided to instead move those into a monolith. And a lot of people are just saying, wait, no way, we're trying to get out of monoliths. Why is this, product that is so, I guess, microservices driven, right, or influenced? Why in the world would they go to a monolith? Can you explain that, what it is that happened, and why it happened?
Yeah, absolutely. So Istio, when we first launched Istio, there are multiple control plane components. I believe there's at least 4. So there's Pilot, there's Citadel, there is Mixer, there's also the sidecar injector components. There's also Gaily components, so there's 5. So when we first released Istio, we thought, Istio, we want to eat our own dog food, right? We are providing all these benefits of microservices. Why can't we use Istio itself to secure the connection among our own control plane components? So we actually run sidecar on each of the control plane components when we first released Istio, except a Pilot, because Pilot was the component that programming all the sidecar, so we couldn't have a secular dependencies on that. But all the other components were running on the sidecar proxy, and we were using that to secure communication, to observe what are the activities going on within our own microservices as part of the control plane. But recently, I think it was a year ago, not just very recently, but a year ago, Istio actually took a pause on our control plane components, and we started to ask ourselves, do we meet the requirements of running microservices, right? Typically, developers are looking at microservices because the services are produced by different teams. The services have their own delivery schedules, right? Because each team can fastly release their services on their own schedule without coordination. And also typically they're using different programming languages. It's free to use whatever language you pick. But we look at Istio control plane components. They were all written in Go, so didn't check that checkbox of using different programming language. And we always release Istio control plane along with the Istio release together. We've never had a release where we just release Mixer or Gaily. In fact, our user doesn't really know, like, how do you install one component of Istio but get the rest of stuff function. We never teach them to do that. We always tell them this is like one thing released together. You always install them together. So that's the second thing we check. The third thing we check is from a user perspective, how are our user going to operate, install, and config these 5 components? And we find out our user actually thought they were complicated. Instead of we install and upgrade and configure one component, they need to do 5. And, especially with multi-cluster configuration, they have to point out to like the Gaily instance, the Mixer instance on the remote plane. So it was very cumbersome for our user. So with that 3 reasons, we come to the conclusion, we don't check the checkbox for building microservices for our control plane component. For the simplicity of our user, it's just best to consolidate them into one single component. So our user have one thing to install, one thing to upgrade, one thing to config, and one logs to check out the things when control plane goes wrong. It actually turned out really well. I actually believe a lot of users come back to us at IstioCon earlier this year. They made comments like Istio is drastically simplified because the control plane component consolidation, and also because the user community was so much focusing on making Istio simple to adopt, with commands like Istio analyze to help you figure out what's going on with your cluster. Yeah, so really interesting journey. I'm glad, the community went through all that. And I'm super excited to see all the outputs from our user, really positive.
Yeah, nice. And I, of course, will give a shameless plug for our Tomasz and I just finished a book that's been published called Strategic Monoliths and Microservices, Driving Innovation Using Purposeful Architecture. Now, the monolith in this case is very purposeful. It has a very specific strategic kind of maneuver to support innovation, ongoing innovation. And I think this is a great example of that. And while we may be looking more at line of business, kinds of applications overall with, say, domain-driven design influence, I think that even kind of technical services, so to speak, or applications can apply the same kind of architecture. Now, question for you, and maybe you don't know this at the sort of internal level, but have those 5 components still maintain their own separate models of, because I think there is a model involved with each of those, whether or not it's, like clearly modeled as a domain model, perhaps not. But do you know if the decision to go with a monolith has still maintained the modularity of those 5 components separate from each other with, careful integration between them where needed, or has everything kind of fused together? Do you have any idea?
So I think you're asking from the code base perspective, right? Are they merged together from a code base perspective?
Yeah, like did you sort of take the 5 individual microservices that kind of represented five different models, if you will, software models, and what was, the components associated with those models. When you brought those into the to a monolithic architecture, did those five um, areas or models stay sort of cleanly separated from each other, but just benefiting from the packaging or the deployment unit of monolith? Or do you see that those five models are kind of merging, maybe getting a little tangled together? Any ideas there?
Yeah, definitely a little bit tangled together. We actually see some of our components are completely merged into Pilot, which was the main component that does like the config the Envoy sidecar proxy. I think the security component might still be on its own within the same Istio repository, but we've kind of removed like the Gaily components. The mixer components is also gone because we distribute that work to Envoy sidecar proxy. The sidecar injector was merged into Pilot. I think many of the security function was also merged into Pilot, but there may be some still remains by its own. Yeah, but definitely the intermingled pattern that you were just referring to.
Okay. Well, maybe it's not as important in this case, but perhaps some months or years down the road, you might recall this conversation and say, maybe we should have kept those five things separate. But I have no idea. I can't offer any suggestions on that. But I was curious. I think that what can happen in those situations is that the code will tend to merge together and kind of be interwoven. But interesting too that you decided to keep the security component separate, which says it's probably at least a separate kind of response, concern, responsibility that's completely different. So interesting.
Yeah, in our case, it's a little bit different because two of the components, like Gaily and Mixer, their function was either removed or distributed to Envoy sidecar, so the control plane no longer needs those functions in a sense. So that was easy. The security, we still need them, so we keep them separate mostly.
Oh, okay. Well, that makes sense then. Yeah. So it's actually kind of become a smaller application now, I guess I
Yeah.
would say. Yeah. Okay. Interesting. Very good to know that. And probably then you're quite comfortable with that merging of the various models, but still with security separate. Nice. Oh, and one other thing that I thought of when you said that Istio is implemented with the Go programming language. I'm sure you have experience with other programming languages. Can you tell the listeners, like, should they be using Go for application development, or is it more for sort of the system level? Which I would say Istio is more of a system level,
Mm-hmm.
of implementation. What's your advice on that? What's your experience with Go?
Well, I would say if you are coming from a background of C or C++, I think Go would be very comfortable for you to pick up. But as an application developer, you should be able to feel free to use the language you feel mostly comfortable, because learning a new language does take time and effort, right? Especially if you don't have C or C++ background, like some of the syntax and the concept in Go could take some time for you to grasp. So I would recommend you to stick with your language if you don't have special requirements.
Yeah, and I think what interests people so much about Go is that it compiles to native language, right? And you kind of get that for free. Personally, I know enough about Go probably to be dangerous, but my understanding of the way interfaces are implemented in the language or designed in the language, that it seems a little odd to me in that use. But maybe, as you say, and I do know C++, and I programmed for 16 years in C and C++ combined, and so I feel comfortable with those, although I would say there are reasons why I'm happy I'm not using them anymore. But that is not necessarily even a point with Go, because Go doesn't have, you're not going to get a segmentation fault from a straight pointer, access or something like that. So, a different level of reason why I would not want to use C or C++ at this time. But it's interesting that maybe system level is the definite specialty use of the language and maybe not so great for applications, but I'm certain that many people are using Go for application level development as well. So it's just an interesting topic to me, not to try to draw some really important contrast or boundaries around its use. But interesting to know that you probably picked it up very quickly with your background.
Yeah, I'm actually not sure I pick up very quickly. That's why I was like, if you don't feel very comfortable about C or C++ and you don't have a reason, maybe you shouldn't. In fact, most of our samples we provide in Surface Mesh are actually not written in Go. A lot of them are in Python, Java, Node.js. So part of the reason is we're trying to teach people, Surface Mesh can support all these great languages for you. So you don't have to stuck on one language if you don't feel comfortable. But with the Istio project, we didn't have a great choice because that's, like you said, it's more system. And also it was started that way, there's no need to change it.
Yeah, really. Okay, so I bring up this topic maybe a little bit shy even of asking, but we learned something good. You're actually polyglot, but using Go and what your team considers the best places. So that's a very responsible decision of you. Yeah. So okay, let's talk about the future with Service Mesh. Where do you think the near future and maybe even a little bit distant future is with Service Mesh and Istio?
So I think the Service Mesh project industry is going pretty wired with a lot of competitors out there, right? We are not doing a great job to our users, I would say, because the fact the user have to spend a lot of time to figure out what's the right service mesh for me and how do I pick, how do I learn. It's a hard space for our user to navigate, I would say. What I certainly hope is, the industry would consolidate on a leading service mesh project, same as Kubernetes, right? I remember 5 years ago, I had to learn Apache Mesos. I have to learn Docker Swarm. I had to also learn Kubernetes. Each have their own syntax. I have to go to different conferences trying to learn, what's the strategic one that we should bet against, right? It's very hard for the user to spend tons of time and energy and money to figure out what's the right one to use because they are afraid of picking the wrong one and they could stuck there and they still couldn't move on to Kubernetes even today, right? We've probably seen that with some of the user. So what I'm really hoping is we could have one service mesh that could be, like the best service mesh or the dominant service mesh for Kubernetes at least. So whoever is batting against the Kubernetes platform, which is the easy bet, they will already know what service mesh they will be using, and service mesh would be fairly boring as part of the infrastructure within Kubernetes. So user would just be enable one thing, they got mutual TS, maybe enable another thing, they can do traffic shifting. So really very much prefer reduce the complexity, the landscape of service mesh for our user.
That's one of my favorite topics, right? Reduce the complexity, force simplicity wherever possible, right? And excellent choice for the future direction. And I have to say, I face and my team faces decisions like not necessarily service mesh, which one do we choose, but even just programming language or cloud environment, what's best suitable for our team, what's the simplest way to go. Should we be using AWS directly, or should we go with Google Cloud Platform, or is there this sort of intermediate platform that simplifies that, and you just don't want to get it wrong? And then, oh, should we be using Java for serverless, as in AWS Lambda, or should we be using JavaScript? And oh, what if, let me ask people, well, JavaScript is great, but if you have a very large application, you shouldn't use JavaScript. Maybe try TypeScript instead. Oh, but TypeScript, and it's just this endless, source of rolling the dice, as it were. It's just like you said, it's kind of this big gamble. What do we decide on? And it's great that Istio and your use of Envoy and so forth has gained this traction that is reassuring to the industry. And this company now, Solo, with $1 billion valuation and a solid, business plan and so forth. This is an excellent position to run with, this kind of decision. So I think you're going to be successful with that. And in conjunction with that statement, or statements, what is the vision of Solo, and where is the future going to take you moving forward?
That's a great question. So Solo, I used to think of Solo as focusing on, application network connectivity, right? Not only just the edge, but also at the service mesh, right? Among your services, which is why you've seen Glue Edge and Glue Mesh product. Most recently, I started to think about Solo as not just, solving these two challenges for a user, right? Solo is now looking at something bigger, not only Envoy, Istio, but also some of the interesting technologies and how they intersect. For example, we just announced GraphQL, right? We are announcing support for GraphQL. So if you want to have a declarative way to get your data, right, GraphQL, we bring them to Envoy and Istio. So if you are microservices looking at GraphQL, that's something we're very interested in support. The other thing is Ebpf, which is another thing that's being a lot of people are asking, how do you position Ebpf and service mesh? So we're looking at providing a complementary solution for having Ebpf on top of service mesh, where you need additional, such as networking layer, system layer observability, where service mesh couldn't provide, or you need additional system level security where service mesh couldn't provide, so Ebpf can fill in. So I've seen Solo is expanding beyond our comfort zone, I would say, beyond what we have with Envoy and Istio. We're now expanding into other technologies where our customer is taking us to.
Yeah, interesting. And yeah, out of your comfort zone. But that's what innovation means, right? And we
Yeah.
kind of wear the lab coat and pocket protector for a long term. Excellent. Now, this is interesting. GraphQL in the sidecar? How
Yeah,
how does
in
that
the
work?
sidecar or in the API gateway.
Oh,
It could be
okay.
both. Yeah. So the idea is very simple. Well, you could have a data service, right, without GraphQL. And in the sidecar, we would be able to generate automatically. We could potentially observe your traffic pattern, generate a schema, or you tell us the schema, and we loaded the schema in the sidecar. And based on the languages, the protocol you're using, we load like an HTTP resolver for you if it's HTTP. So that resolver can help you along with the schema to resolve the declarative query of GraphQL. So it's pretty interesting technology. We're actually innovating at Solo.
So does that mean that maybe Solo is moving toward artificial intelligence? That could make you a double unicorn. How do you determine, um, based on observation of traffic and so forth, that a schema, uh, this particular schema, needs to be generated, for example?
Yeah, that's a great question. Yeah, so these are the things we're still innovating. So yeah, it could be, based on your common traffic, or if you are not trusting the generator, maybe it's best to just provide your own schema in that case. So you tell us exactly what type of schema you want to support.
Yeah, all very interesting and intriguing thoughts. So we look forward to, yeah, the future of that, and um, let's try to have another conversation later when we see those new components and so forth appear. That'd be very interesting to know about.
That sounds great. Yeah, I would love to come back and chat with you.
So, anything that I've left out, anything that you would like to say about Service Mesh, Istio, Envoy, Solo, anything like that that maybe just I've not thought of?
No, this is great. I really
Okay.
enjoy our conversation. Thank you so much for having me, Yvonne.
Thank you so much for joining us here for the podcast. And again, best wishes to you, and we'll talk to you soon.
Thank you so much. Thanks for having me.